Okay, let's try a second example here. So we're going to do domain and range. We're also going to sketch the graph. We recognize right here that we have, sorry about that. We recognize right here that we have a transformation of a radical function. So you may want to write this down first, that the original function is the square root of x. And of course, our table of values for the original function stays the same. It's the exact same values, square root of 0, 0, and so on. We start with a dot, we end with an arrow. Once again, you don't have to put that dot and arrow on your table of values. It's just there to remind you, but you have to have it on your graph. And then we're going to do a mapping notation. So whenever you are given an equation in transformational form, you're going to do a mapping. The outside parts, the negative and the plus 1, are the y values, which stay the same. The x values switch up, and that's what's on the inside. So we now have x minus 3, and the negative in front flips over. It's still a negative. It's a negative 1, which is really a negative 1 over 1. When you get the reciprocal of that, it's still 1 over negative 1, which is negative 1. The reciprocal of negative 1 is negative 1. But if that was like a negative 2 in the equation, in the mapping notation, we would have negative 1/2. So now what we do is we plug these points into the mapping notation to get our new table of values. And as we do that, okay, you're going to wind up having these values right here. You're going to wind up having these x values. And once again, negative 12, we may not get that on the graph. The y values are going to look something like this right here. And away we go. Let's try to the best of our ability to get 4 of these points. The first one is a dot. The last one is the arrow. So let's do this. Okay, I have a graph right here that's going to look something like this. And I put in my points of negative 3, positive 1. We have a point there. Negative 4, positive 0. I mean just 0. Negative 7, negative 1. And will we get 12? Sort of. It's kind of there. All right, we can put it right here somewhere. It's going to look like this. Okay, now that makes sense because the original function, the square root of x function, starts at 0, 0 and goes up and to the right. So if you compare your mapping notation, what's supposed to happen, with your graph, what did happen, you can see there are 2 reflections here. Both the x and the y are negative in the mapping notation, so they are reflections around the y and x-axis respectively. And you can see right here, okay, that it flips over both the y and the x-axis. So that's good. Okay, now notice here, okay, we also have it shifting. Its original 0, 0 point, the starting point, has moved to the left 3 units. So that's a horizontal translation, and it's moved up 1 unit, which is a vertical translation. And it doesn't look like there are any vertical or horizontal stretches here. So we have the graph finished. Now, if we do domain and range, okay, we can do that next. So we can say that our left bound is negative infinity. It goes all the way to the left. But the right bound is at negative 3. It's not going to go any further to the right than negative 3. And then for our y's, it goes down to infinity but reaches a maximum y value of positive 1. So we have our domain and range, and we have our graph.